Okay, so what we are doing is gradient boosting. So gradient boosting made up of two words. First thing, gradient and boosting. Why gradient is because gradient tells us which direction would result in maximum loss. So we move towards the against of it. Okay, so the first thing is clear. Second thing, boosting. Boosting is a ensemble learning technique. Ensemble means combining multiple models. That is what we are going to do. Okay, so boosting is basically taking a simple model, then improving the model, considering the errors that the first model caused, and now the second model is not causing those errors, but there are still some errors in it. So then step three, then again a model with the errors, with improving the errors that the earlier model caused, and then if required another model. So yeah, and yeah, gradient boosting would be helpful to you if you are trying to do two types of both the thing like regression and classification, both the things. It would be helpful. So the first thing, regression. For regression it would be easy, and for classification it would be just a tiny bit difficult. The loss functions would be different. Let's consider a simple example of regression. Okay, so the step one, you have gotten this data. The size of the house are 1 2 3 4, and accordingly their prices are like 10 20 30 40. So the step one is you just take the mean of it, and the mean is 25. So now you are considering that your model is just predicting 25 irrespective of the size. So for some houses it would be correct, for some houses it would be not, and for some houses it would be correct even though it is just a simple number is because it is the mean of the actual numbers. Okay, then what we'll do, we'll take the difference between the actual and the simple prediction that we have done, and the difference would be called residuals. The residuals are minus 15 minus 5 plus 5 minus 15. So now the model would think it has to make a split, so it would make a split here only, 2.5, because that is the place where the positive and negative differences are there. Like these differences, minus 15 minus 5 plus 5 plus 15. So if you draw the 2.5, like the size 1, 2, 3, 4 is like 1, 2, 3, 4. So if you draw a split here of 2.5, it would be easy. So let's see if there is a diagram drawn. Okay, so the diagram is not there. Just consider if you are drawing the split of 2.5, like here size is less than or equal to 2.5, size is less than greater than or greater than 2.5 here. So a decision tree is there. First it was just a simple model, then now we have a simple decision tree. Okay, so if the size is less than, if the size is less than this, we have to increase it, because here you can see the residual is negative. We have to increase the residual here, so we'll just calculate its average, like average of 5 and 15, it is 10. So we'll just increase it by 10. If the size is less than 2.5, then we'll have to increase the residual, getting plus 10, and here minus 10. Simple. I guess the tree is here if it is possible to see. Yeah, here you can see size is less than 2.5. Yes, increase, decrease. Size is greater than 2.5. Increase. And how did we get the value 10? Just by taking the average. Okay, this is the simple thing. And now we have our values of minus 10 and plus 10. So whenever there is when we are training the model, if you are getting size less than 2.5, it would decrease it by 10. If you are having more than 2.5, it would increase it. Okay, so now we have these values of minus 10 and plus 10, and we'll make the actual prediction change, like the actual predictions would be different now, by like take the old predictions that was like 25 25 25. Here you can see the predictions that we made with the earlier model, and now we'll update those prediction with the new changes that we are considering here. The new changes are minus 10 or plus 10 depending on the size of the house, and we'll multiply it by learning rate, just so that it won't be a sudden change and the model won't overfit. Okay, so now here we have my 20 30. So now our model is predicting 20 20 30 30. Here you can see. Okay, so now this process would be repeated again and again. Now according to 2020 30 30, the residuals would be calculated. And how would the residuals will be calculated? Here you can see the actual predictions are 10, 20, 30, 40, and the differences between them would be calculated here. Minus 10, 0, 0, plus 10. Okay, so now again there would be a split, and it would consider, is it less than 2.5, size less than 2.5? Yes, okay. Is the size less than 0.5 or whatever, or size less than 1? Here, like the decision tree, new tree would be there, and this tree would be an improvement on the earlier tree. Okay, and now according to the split, it would be either minus 10 or plus 10. And yeah, that is how the regression would work.